Let's go ahead and take a look at 7.2.40 using the normal calculator. And here's a real-world situation where data has been collected. We know the average amount of time a car spends at a drive-through is 130.7 seconds. And then we know after the data has been collected, we also know the standard deviation is 28. So there's going to be some normal distribution with respect to the amount of time a car spends. Most of the cars are around 130, but you have some that are greater than and less than 130, and it's spread out by the 28 seconds because that's the standard deviation. So what that would look like, again, to answer questions like this, now that we know that, what is the probability that a car spends less than 85 seconds? Normal calculator, put 85 here, the less than, this is the normal calculator again, those tick marks, and so when you compute that, it looks like you would end up with 5%, around 5% of the cars would spend less than 85 seconds. Remember, the mean is 130.7, and then the standard deviation is 28. And so you can see how the values would be distributed there. We can then answer questions like, so that's A is done. What is it? The probability it's more than 173. You would just put 173 here, greater than, and then compute. So 6.5% chance that it's greater than 173 seconds. What is the proportion of cars that spend 2 and 3 minutes? It's a trick question. These are in seconds. So between 2 and 3 minutes. So this would be 120 seconds and 180 seconds. Compute that. And so 60.9% of the cars would spend between 2 and 3 minutes. I had to convert the minutes to seconds. 60 seconds in a minute. So trick question there. And would it be unusual for a car to spend more than 3 minutes in the drive-thru? And so in this case here, let's go back to the standard one there. More than 3 minutes, more than 180 seconds, compute, and it's 3.9%. Since it's less than 5%, we would say in this case that it is unusual. The answer for this one is the probability says more is what did we get again? We got 3.9%. So yes, it would be unusual. So it would be unusual since the probability is less than 5%. That's how you would answer these questions here using the normal calculator. Again, you could use the normal distribution table or the Z table to do that, but it's much easier to use StatCrunch here.